Testing 1, 2, 3. All right, let's begin. Hello, class. This is Ben Keys, a TA for General Chemistry at Marquette University. Today I'm going to show you how to do your Avogadro Lab, at least the Excel for it. So, in the Avogadro Lab, hopefully you've gotten all of the following numbers and you've put them into your table. And we haven't done that yet, so let me take this away just so I can show you. All right, so you should have the dish diameter, the mass of the dish, and the mass of the dish and beads. You should have 3 trials of that. You should have recorded on the side, and this is the same for everybody, the molar mass of glass beads and the density of glass beads. Please make sure there are no units anywhere in your Excel. You can have these words on the side, but there should be no units. Then you're going to need to have your fatty acid used. You might have a different acid than I have, in which case just make sure your numbers match your acid. You should have its molar mass, the density of the pure fatty acid, the density of the fatty acid solution in alcohol, and the volume by volume percent of fatty acid solution. Make sure you have all of those in here. For the first part of part 2, you should have the mass of flask and water, the number of drops, and the mass of flask, water, and fatty acid. You should have 3 trials of that. And for the second part of part 2, you should have the average diameter of the film. If you only have your diameters of film, please just simply go over here. You can either use the average or mean function, or you can just say you had 35, 32, and 32. You can just take all of those, add them together in Excel or with your calculator, doesn't really matter. And then you will just simply divide that by 3, and that'll be your average. See, this would be 33 as we found here. You don't have to do that in Excel. Just whatever way is best for you to get your average diameter of film calculated as quickly as possible. Last note before we begin, if you're having trouble putting this subscript into Excel, so let's just click on this one. So go up to the line here and select the A, and then you're going to do Control 1, which pulls up this nice Format Cells window, and then you'll just make sure you click this little subscript box, make sure it's checked, and then you hit OK, and that's how you do subscripts in Excel. Alrighty, let's begin. So the first thing you want to do when doing the Excel for this lab report is you want to determine what your mass of the beads monolayer is. So you're going to do equals, and you're going to take your mass of dish and beads, and you're going to do minus, and you're going to take your mass of dish. Enter. Alright, that's great. Let's drag it across by hitting this little box in the bottom right and dragging it for the other 2 trials. Perfect. That's exactly what we want. Alright, now we're going to do the volume of the beads. So for the volume of the beads, the equation given in the handout is equal to, we have the mass of the beads, and we're dividing that by the density of the beads, which remember is over here. And that'll give us a number that looks something like that. You can drag that across. Not like that. You actually have to put in dollar signs. My bad on that one. So in here, just make sure you do little dollar signs in both cases. Actually, the B, you don't need the dollar signs. It's just the F4 value. So in the F4 value, put a dollar sign before the F and a dollar sign before the 4. And then if you do that, you should be able to drag it across. And voila, there we have some more values. So anytime you're trying to use a box that doesn't move, you're not just selecting things that are happening over here, you need to make sure you put your dollar signs in front of the letter and the number. That way it locks this box is the one that we're using. Alright, so that gives you the volume. Then for the area of the film, we are going to do equals, and you're going to find pi, so type in pi, then click on it. You see it gives you a little forward parentheses. Let's close that immediately. This denotes the exact value of pi for you. So pi, then we're going to do times, so a little star, then we're going to put this in parentheses. We're going to do the diameter of the dish divided by 2. I'm going to close those parentheses, and then we're going to do is the caret and the 2 to square it. And so that's going to give us the area of beads monolayer. And now that one we can just drag across again. Alright. Now we're going to get a diameter of 1 bead. So for the diameter of 1 bead, we're just going to take the volume divided by the area, which should give us something like that. And you can once again drag it across. Alright, now that we have the diameter of 1 bead, we're going to do the volume of 1 bead. And for that, you are simply going to start with equals, parenthesis, 4, do the pi thing again, so click on pi, close the parenthesis, Actually, you should probably, let me go back here quick. You should do 4 times pi, my apologies. 4 times pi, close the parenthesis, divided by 3, then close the other parenthesis, then times, then open parenthesis, and then you should do the diameter of the bead, which is what you just got, so that cell right there, and then divided by 2, close the parenthesis, and then you're going to caret 3 to cube it. All right, and that'll give you the volume of one bead. Now you've gotten the volume of one bead, you can just drag it across. Now we're going to do the mass of each bead. So for the mass of each bead, we're simply going to take equals density from over here times, and you're just going to multiply it by the volume of the bead, which you just found here. Perfect. Now remember, in this one, we have to put the dollar signs in here, so just go ahead and do that quick. And once you've done that, nope, I don't know what it did. Oh, I see, I just moved it down. All right, very good. And then you're just going to drag it across, and that'll give you those right there. All right, now we're going to calculate Avogadro's number for part 1. So to calculate Avogadro's number for part 1, you're going to do equals, and you're going to select this molar mass over here, and then you're going to divide by the mass of one bead. And then once you've done that, you should get something like that. Now, remember, before we drag it across, we need to add our dollar signs on this F2. Not that. Dollar sign. All right. And now we should just be able to drag it across. All right. Very good. Now, in order to do the NA average, we are simply going to do equals average. See this average right here? So this is the other way to do the average besides just actually typing them out one at a time. And you're just going to do that, with commas in between. And this will give you the average of those 3 values. All right, so that's our average. This is actually not so bad, especially considering we're trying to calculate Avogadro's number using glass beads. For the standard deviation, you're going to start typing standard deviation. So we have standard deviation P. That's going to give us based on the entire population. And then this other one is going to be based on a sample. In this case, I think we'll just use P. It doesn't overly matter, so just go ahead and use whichever one you like better. If it does matter, we'll let you know. And then we can go ahead and find that. So there's our standard deviation. And then we have our percent error. And remember, our percent error calculation, we can find at the very bottom. So for percent error, we are simply going to do, I don't remember where the absolute value function is, so we're just going to do it like this. So this number is larger than Avogadro's number. So you're just going to take this number, and then you're going to subtract Avogadro's number, which is 6.022 e to the 23rd. You're going to divide that by Avogadro's number, 6.022 e to the 23rd, and you multiply by 100 to make it a percent. Now, if your number is smaller than Avogadro's number, you instead want to do 6.022 e to the 23rd minus this cell, and then still divide by 6.022 times 10 to the 23rd and multiply by 100. And that should give you some kind of percent error. So we have 30.5% error, which really not very bad. So pretty acceptable given that we were using glass beads. And that concludes all we have to do for part 1. So let's go on to part 2. So in part 2, the first thing we need to do is we need to do the volume of the film. So the first thing we're going to do for a volume of the film is we are going to, so I don't know why this area of the film is here. Ignore that. For the volume of the film, we are going to do equals, and we are, oh, I see, it's because I'm on the wrong step. It's up here. Ignore me for a sec. All right, now pay attention to me again. All right, so the mass of the fatty acid solution is equal to this one minus this one. Great, that's what we like to see. Just drag it across. Excellent. All right, now we're going to do the volume of all drops. So this is the volume of the film, or volume total. So pretty easy stuff. For this one, all you're going to do is equal. You're going to take this mass value that you found, and you're going to divide by the density of the solution. So the fatty acid in alcohol, this one right here. And you're going to enter. Now, remember, we just did this number divided by this number. So we have to lock this number in place. So we go over here to this E18, put our little dollar signs on it, all right? Okay, Perfect. And now I can drag it across like normal. Great. Now we're going to calculate the volume of one drop. That's pretty easy. So all you're going to do is you're going to take this cell right here, and you're going to divide by the number of drops you have, which you have up in this cell. And you can just drag that across. So now we have the volume of one drop. And then for the average value of one drop, we're just going to do equals average of these three cells. All right, now you have the average volume of one drop. Excellent. So we have it right here. That's all you do for the first part of part 2. Now, we're going to go on and do the second part of part 2. So the first thing we're going to do is we're going to do the area of the film. For the area of the film, you're just going to go equals. You're going to do the pi thing again. Don't forget to close that parenthesis. And then you're going to do times. And you have a new set of parentheses here. You're going to do your diameter of the film, which you have right here, this average one, see? And you're going to divide by 2. And then you are going to square that with caret 2. Very nice. And now you can drag that across. All right. Now you want to do the volume of the film. So for the volume of the film, we're going to start by going up here. We're going to do equals, and we're going to click on this box right here, the volume by volume percent of fatty acid solution. So click on that. So you have that one. Then you multiply by volume of drop. It's this box right here, this average volume of drop. And then you get to divide by 100. Divided by 100. Enter. Perfect. And in this case, this is going to be the same for all of the trials because literally we're using the same volume of one drop here and we're using the same fatty acid here. So actually the fastest way to just copy this over is to just Control C, Control V. Nope, not like that. I don't know why I did that. Never mind then. In that case, just go over here and do the dollar signs because I don't really feel like figuring it out any other way. And you're going to do it in both of them, and then you'll be able to just drag it. Alright, very nice. And now we can just drag this across. Oh, wonderful. Okay, look, it's the same value every time. Alright. Now that we have gotten the volume of our film, we're going to find the diameter of the molecules. The diameter of the molecules is just going to be equals the volume divided by the area. So if you take volume over area, you'll get something like this. You just drag it across. Perfect. Alright. Now that we have the diameter of one molecule, now we're going to take the volume of one molecule. So for the volume of a molecule, you're just going to do equals, and let's start with some parentheses, 4 times, do the pi thing. Make sure you close the parentheses on the pi, divide by 3, close parentheses. Then you're going to multiply by, and you're going to take the diameter of the fatty acid molecule from up here. You're going to divide by 2. After you divide it by 2, you're going to close the parenthesis. Then you can caret 3 to cube. Excellent. Look at that. What a nice value. All right, now you can bring these over here. Now we're going to do the mass of a molecule. So this one, you're going to do equals, and you're going to find the density of the pure fatty acid up here. Click on that box. And then you're going to multiply that density by the volume of fatty acid molecule. You just calculated right here. Excellent. So we get something like that. Now let's put in some dollar signs on D18. Why don't we? Alright, very nice. Now we can drag this over and get the other two. Very good. And then, now that we've gotten that, looking at this, those are pretty similar values. Okay, not a concern though. Alright, anyway. Avogadro, you might have something that happens like this where you get pretty similar values in 1 and 3 or stuff like that. Actually, you will if you have this average diameter being the same. And then we're going to do Avogadro's number in the last box. So that's going to be equals. You're going to find your molar mass up here, right here. And you're going to divide that by the mass of the molecule, which you just got. And that should give you something like this number. Now make sure you put your dollar signs in C18 right here, or whatever other cell you have that you're doing. And then you can just drag it across, and that should give you your values for Avogadro's number. Now we can take the average of that. Pretty easy. You just do this average thing again. Select these 3. No, don't do that. Actually, I believe you can do that, but I'd rather just do this. Okay. That'll give you the average. You can also do the standard deviation. Once again, Your pick. I'll use this one. Very good. And percent error. Our value is larger than Avogadro's number by quite a bit, actually. That happens, though. Let me put a parenthesis on that, actually, so it's equals Avogadro's number minus, I'm sorry, not Avogadro's number. We do ours first because ours is bigger. It's our number minus Avogadro's number divided by Avogadro's number, and then we just multiply by 100, and that'll give us our percent error. So as you can see with this TA data we used, we had 99,422% error. So don't feel bad if you have a ridiculously high number, because this is a real TA's data. With that, I believe I've showed you everything you need to do except for one thing. So when you are putting stuff into your tables in Excel, there's only two things left to do. One, you're going to need to show formula view. So if you want to show formula view for your Excel, just go over here to formulas and click on show formulas. And as you can see, you can now copy this stuff into tables in your PDF or Word or whatever you're doing. So make sure that you show this for your calculations. You don't have to show any other calculations if you show this. So like literally all you need to do is just show us this formula view, and that handles your calculations for the lab, which is great because that's your discussion for this lab. So go ahead and do that. And then once you've gotten that all out of the way, you also will need to put the data in properly as this right here. And you need to increase and decrease the sig figs. Let me search that quick. You can do it manually, but you know, I don't think you want to. I know there's a command here somewhere. Uh, all right, so in Excel, click on, say, this one. It's not the great one. All right, well, I don't want to waste any more of your time making this video or mine, so basically you can Google it to try to figure it out, or you can just copy all of these into tables in Word or whatever, and then just chop off any of the numbers that you don't want and round appropriately for sig figs. So with all that all said, I think I've showed you everything you need to do the calculations perfectly for this lab. Make sure you use sig figs when doing these numbers, and make sure you also have a second copy of the tables with formula view. Thank you so much, and have a nice day.